Lesson 1.2.1, adding and subtracting polynomials. So this is going to be one of the easier lessons for us. And of course, we're going to start with example 1. Okay, oops. So example 1. Find the sum of 4 plus 3x plus 2 plus x. So first thing we notice is that these two here are being added. So there's no need for a prior step before we go ahead and we tackle this out. So we have, since it is an addition problem, we can go ahead and start with just dropping the parentheses. Okay, so again, only when we're adding it, we can jump straight to dropping the parentheses and writing this out as one line. So we have 4 plus 3x. Since this is a positive 2, I'm going to put plus 2 plus x. Okay. Now remember that we want it in a standard form, so we want our variables to always go first. So first thing I'm going to do is I'm going to collect my like terms. I have 3x here, and I have a 1x here. So 3 plus 1 is 4, so we have 4x. Now I'm looking at my constant terms. So I have a 4 here, and I have a 2 here. Those are like terms as well. So 4 plus 2 is 6. And that's my final answer. I have no other terms to collect, and I can't simplify this any further. So our answer is 4x plus 6. Now example 2. Find the sum of 7x squared minus x plus 15 plus 6x plus 12. So again, first thing we notice is that there's an addition sign between these two parentheses, so we don't have to do any distributing, right? There's no point in distributing a positive 1. Anything times 1 is just itself. So now we can rewrite this, dropping these parentheses. All right, I'm just going to drop all those parentheses. So I'm going to have 7x squared minus x plus 15. Since this is a positive 6x, it's going to be plus 6x plus 12. Okay? And remember, you always want to start with your highest exponent. So if I'm looking at this, the highest exponent I have here is x squared, right? And the term is 7x squared. If I'm looking at all these other terms, none of them have a x squared, which means there's no like terms for that 7x squared. So we just go ahead and we bring that down, right? 7x squared. Next thing we look at is x to the first power, or just x. If we're looking at those, we have a negative x here, and we have a positive 6x here. So now we combine those two. 6x minus 1x gives us 5x. So we have plus 5x. And last thing we do is we look at our constants. We have that positive 15 left over, and we have that 12. 15 plus 12 gives us 27. And that is our final answer. We have nothing else to combine, right? We have no other like terms, right? So just be careful, because this is x squared and this is x. Those are not like terms. Okay, example 3. Example 3, small typo here. This should be subtraction. Let me fix that up a bit. Subtraction. Okay. First thing, I'm going to go ahead and rewrite this one. This one's going to require one additional step. So you have x to the 5th plus 8 minus 3x to the 5th plus 5x. Okay, so last two previous examples, we had addition signs between the parentheses. Now we have a subtraction sign, right? Because we're finding the difference here. So key thing, we have a minus sign there. So remember that there's an invisible 1 here in front of this parentheses, which means we're going to be distributing this negative 1 into the parenthesis, right? if we're multiplying by positive 1, it all stays the same, which is why we drop the parentheses. If we're multiplying by negative 1, it's going to change all the signs in the parenthesis. So starting with the left parenthesis first, we have x to the 5th plus 8. There's no negative sign out in front there, so we don't have to distribute. So we have x to the 5th plus 8. Okay, so now we got to start our distribution. First thing we're going to do, take this negative 1 and multiply it to 3x to the 5th. Negative 1 times 3x to the 5th gives us negative 3x to the 5th. Now we're going to take our negative 1 and multiply it to 5x. Negative 1 times 5x is minus 5x. Now from here we have nothing else to simplify so far, so we can go straight to collecting our like terms. Remember, standard form, we got to have our highest power first. So our highest power, obviously 5, right? X to the 5th power. So we have two terms that have x to the 5th power, and we can go ahead and combine these. So negative 3 plus 1 gives us negative 2x to the 5th power. Now we look for our next term. We have an x to the 1 power here, and no like terms for it, so that's minus 5x. And our last one, we have that lonely plus 8. So looking at our final answer, there are no other like terms to collect, and it is in standard form. Okay. Example 4. Find the perimeter of the figures to the right. So remember, perimeter is when we're adding all of these sides together, right? You're adding all sides of the shapes together. So if you're looking at perimeter here, I'm going to do the work on the left side here. We have x plus 14, right? So we have this here, plus x plus 14, plus 2x plus 36. Okay, so we're adding all three of those sides together. First thing we do, we look for the highest exponent for the variables, and it looks like we just have an x to the 1 power. So we have an x there, we have an x there, and we have 2x there. So 2x plus x is 3x plus x, we have 4x there. And now we look for the next set of numbers. So we have just our constants left now. We have 14, and we have 36. So now 14 plus 14 is 28, plus 36 gives us 64. So our perimeter there for that triangle is 4x plus 64. It's in standard form. Our highest power is first, and then our constant follows. And we no other terms to collect. Okay, going on to the square. So perimeter, same thing. We got to add all the sides together. But this one is, we can kind of do a little shortcut here. So notice how we have, and we could have used this for the previous example too. We have two of these 3x plus 6's. So what we can do is write it 2 times 3x plus 6, and we also have 2 of these x plus 2's. So it would be plus 2 times x plus 2. Right, so that way you don't have to write all this stuff out individually 4 times each. And we know when we see a number outside of parentheses, we're going to have to distribute these. Right, so distributing these out, 2 times 3x gives us 6x. 2 times 6 is 12. Plus 2 times x is 2x. 2 times 2 is 4. And now we go ahead and combine our like terms. We have 6x and 2x, right? We've got to start with the highest power variable first, and it just happens to be x. So we have 8x And our last two constants, 12 plus 4 plus 16. Okay, so just a little shortcut. I mean, you could have done 3x plus 6 plus x plus 2 plus 3x plus 6 plus x plus 2, but it's a lot more work. It's a lot more writing.